Did you know that every year farmers around the world coax over 50 million metric tons of mangoes from the sun-baked orchards of India, Mexico, Thailand, and Florida? Yet few of us pause to consider the journey from flower to fruit stand, let alone from fruit tray to glass of vibrant orange juice. Have you ever wondered how those plump drupes, glowing in shades of emerald, gold, and ruby, are grown under precise irrigation regimes, hand-harvested at peak ripeness, and then transformed in high-tech processing plants into silky smooth juice, bursting with tropical sweetness? Pull on your boots and follow one mango's odyssey, alongside millions of its kin, from flowering panicles through orchard management, harvesting, cold chain logistics, and finally into aseptic cartons and refrigerated bottles that land on grocery shelves across continents. It all begins long before a single blossom opens. Mango cultivation thrives in the humid tropics and subtropics between 30 degrees north and 30 degrees south. Farmers start by selecting grafted saplings of elite cultivars. Think Alphonso, Tommy Atkins, Kent, Hayden, Kate, and Adolfo, each chosen for a balance of flavor, yield, disease resistance, and shipping durability. In nurseries, these saplings take root in raised beds under shade cloth, where automated misting systems maintain humidity at 80 to 90% and temperatures at a steady 28 degrees Celsius. Drip irrigation emitters deliver exactly 0.8 liters per hour per plant, ensuring roots never dry out or become waterlogged. Within 8 to 12 months, sturdy young trees reach 1 meter in height and graduate to the orchard. Orchard design follows a precise grid, trees spaced at 8 by 8 meters to optimize sunlight interception and air circulation, reducing fungal disease pressure. Under each tree, buried soil moisture sensors communicate with a central control unit. When volumetric water content dips below 20%, pivot and drip systems flood the root zone until readings climb back to 35%. Fertigation injectors dose soluble fertilizer blends every 2 weeks, typically a 20-10-20 NPK mix with micronutrients such as zinc, boron, and magnesium, tailored by leaf tissue analyses to prevent deficiencies that could stunt flowering or reduce fruit set. Come spring, the trees bloom in a riot of ivory panicles spanning 15 to 30 centimeters. Growers often release rented hives of honeybees and bumblebees at a density of 5 hives per hectare to ensure thorough pollination. Native bees and flies supplement the effort. Within 7 days of bloom, tiny fruitlets, each a potential mango, begin to swell. Orchard crews then hand-thin clusters so that no more than 2 to 3 fruit remain per panicle, a labor-intensive practice that channels the tree's resources into producing fewer but larger, more uniform mangoes and prevents branch breakage under heavy loads. As summer heats up, the drupes grow rapidly, sometimes increasing their mass by 50% weekly. Canopy management comes into play. Foresters use motorized pole pruners to open the tree's interior to sunlight, and ground crews apply reflective mulch around the drip line to redirect light upward, sparking more uniform skin coloration. Meanwhile, integrated pest management specialists monitor leaf traps and pheromone lures for thrips, fruit flies, and mealybugs. When insect counts exceed economic thresholds, targeted beneficial insects or ultra-low volume botanical sprays intervene, preserving both yield and ecosystem health. Maturity assessment is a blend of art and science. Field technicians use handheld refractometers to measure soluble solids, degrees Brix, on a weekly schedule. Export mangoes generally require 12 to 14 degrees Brix, while those destined for local fresh market sales may be allowed to ripen to 16 to 18 degrees Brix for maximum sweetness. Simultaneously, colorimeters gauge the loss of chlorophyll in the skin, and firmness testers record flesh compressibility. When fruit meet predefined indices, for example 13.5 degrees Brix, 45% skin blush, and 5 kilogram force on the penetrometer, the harvest window opens. Harvesting is entirely manual. Crews don safety harnesses to climb ladders or work from hydraulic lifts, carrying 20 kilogram padded bins secured to hip belts. Using curved blade clippers, pickers twist and cut stems just above the fruit shoulder, gently lowering each mango into the bin to prevent bruising. Experienced pickers can harvest up to 300 kilograms per day, their practiced eyes spotting the exact gradient of blush that signals artistry and timing. Bins fill and are carted to the edge of the orchard, where refrigerated transport vehicles, pre-cooled to 10 degrees Celsius and 90% relative humidity, await to whisk the fruit to the packing house within 2 hours, maintaining a rigid cold chain that slows respiration and delays ripening. At the packing house, the mangoes pass through an initial ultraviolet C sanitizing tunnel, dosages calibrated to 1.0 joules per square centimeter, to reduce surface pathogens without affecting flavor. Next, fruit tumble on vibrating conveyors under high-pressure water jets at 2,500 kilopascals, stripping field dust and pesticide residues. A pneumatic destalker station removes any remaining petioles. Then comes optical grading. Hyperspectral cameras scan each mango in microseconds, reading skin color distribution, size, and defect detection. Fruit off color or with blemishes are automatically diverted to secondary lines for puree or jam processing. Only the top-grade mangoes advance to fresh-cut trays or export bins. Fruit bound for fresh-cut mango trays follow a different path than those destined for juice. The top-grade mangoes, first choice, are hand-sorted one last time. Then a belt of oscillating stainless steel peeler blades removes the thin epidermis, preserving nearly all of the rich orange flesh. Pneumatic push paddles then split each mango into two cheeks, ejecting the central stone into a reject chute. The cheeks slide under slicing units that dice them into uniform 12 by 12 millimeter cubes, which tumble into mesh baskets. A gentle centrifugal dewatering drum spins at 3,000 RPM, extracting surface water and concentrating the sugar content for a juicier bite. The cubed fruit moves into modified atmosphere display trays, nitrogen flushed before sealing, to extend shelf life to 21 days under refrigeration. Mangoes earmarked for juice instead advance into the processing plant's pre-treatment hall. Bins are tipped onto gravity-fed flumes where debris floats away. High-pressure wash tunnels, 2,000 kilopascals, blast fruit clean, while 360-degree rotating brushes exfoliate any remaining lenticels. An infrared vision system detects overripe or underripe fruit by analyzing spectral reflectance in the near-infrared band. Fewer than 5% of fruit typically get diverted away from the premium juice line. The heart of the juice operation is the peeling and pulping module. Mangoes enter a cascade of hot water scalders, 55 degrees Celsius for 30 seconds, loosening the peel and inactivating polyphenol oxidases that cause browning. A belt of soft rubber rollers then slips off the peel, while a pneumatic guillotine severs cheeks from stones. The cheeks proceed to twin-stage colloid mills, first macerated under 150 bar to rupture cell walls, then pass through a 0.5 mm screen, yielding a homogeneous puree. Real-time refractometers confirm sugar levels at 16 to 18 degrees Brix. pH probes ensure the natural acidity lands between 3.8 and 4.2, the sweet-tart balance that defines top-quality mango juice. This puree separates into two streams. The first heads to an aseptic UHT line. The pulp is flash heated to 135 degrees Celsius for 2 seconds, then sterile cooled to 4 degrees Celsius. This kills all pathogens while preserving fresh-cut flavor and vitamin C. An inline homogenizer at 200 bar breaks down any remaining pulp particles to under 80 microns, preventing sedimentation. The product then fills sterile Tetra Pak cartons under laminar flow conditions, followed by nitrogen purge, cap sealing, and hermetic closure. These cartons can sit at ambient temperature for up to 12 months unopened. The second stream heads to fresh-pressed juice lines for a clearer product. Cubed cheeks enter belt presses with woven mesh membranes. 80 bar of hydraulic pressure squeezes out clear juice, leaving behind coarse puree used in smoothies or frozen pulp blocks. The juice flows through plate heat exchangers, preheated by outgoing pasteurized juice in a counterflow design, cutting energy use by 30%. A gentle pasteurization at 85 degrees Celsius for 30 seconds eradicates spoilage microbes while retaining aromatic esters. The juice then travels through pneumatic pinch fillers into PT bottles or glass bottles at speeds up to 1,000 bottles per minute. A final nitrogen blanketing step displaces residual oxygen, creating a microatmosphere that preserves flavor. Inline vision systems verify fill levels, cap torque, and label alignment, rejecting any container that drifts outside plus or minus 2 milliliters or shows off register branding. Byproducts from both lines feed circular economy loops. Mango stones, about 10% by weight of incoming fruit, head to expeller presses where kernel oil yields 7 to 9% oil content, sought by cosmetic and nutraceutical firms for its unique fatty acid profile. Peel and fibrous pomace are dried in belt dryers at 60 degrees Celsius and milled into pectin-rich powders used as gelling agents and animal feed. Effluent from washing and peeling runs through equalization tanks, anaerobic digesters, and membrane bioreactors. Biogas captured from digesters fuels the plant's boilers, meeting 50% of its energy needs. Residual thermal energy from UHT sterilizers preheats scalding water, minimizing fossil fuel consumption. Finished juices and purees are palletized by robotic palletizers, 84 cases per minute, wrapped in stretch film and staged in refrigerated docks. A fleet of reefer trucks, maintained at 4 degrees Celsius for chilled juice, ambient for aseptic cartons, distributes product within a 2-day radius. Local retail outlets receive fresh pressed lines within 24 hours, while aseptic cartons ship nationwide or to export hubs serving Europe, Asia, and the Middle East. Each pallet sports a QR code linked to a blockchain ledger recording orchard GPS coordinates, harvest dates, processing parameters, and QA test results, providing full traceability from farm to fridge. At the grocery, consumers peel back caps on chilled bottles or tear open ambient cartons. Unaware of the 3-month odyssey or the orchestration of bees, satellites, sensors, conveyors, and scientists that made that sip possible. Yet every glass of mango juice epitomizes a tapestry of tradition and innovation. The pollination hum of bees in sun-dappled groves, the precision of irrigation valves dancing under microclimate control, the click of harvest clippers in early dawn light, the hypnotic whirl of colloid mills in high-tech plants, and the gentle hiss of steam as juice flashes through pasteurization.
The journey of our French fry begins long before it enters the factory floor. It all starts with sourcing the highest quality potatoes from trusted farms. These farms follow strict agricultural practices to ensure that the potatoes are grown in nutrient-rich soil, free from harmful chemicals, and harvested at just the right time for optimum taste and texture. Upon arrival at the facility, every potato undergoes a thorough inspection. Automated sorting systems and experienced quality control technicians work together to weed out any potatoes that don't meet the company's high standards. Size, shape, color, and firmness are all meticulously checked. Only those tubers that pass the rigorous criteria move on to the next stage. This attention to detail is crucial because the quality of the raw potato directly impacts the flavor and texture of the final product. At this point, you might wonder, why is quality control so important? Well, each potato is a promise of consistency, crunch, and that irresistible flavor you crave with every bite. And in a world where mass production meets gourmet taste, nothing is left to chance. Once the potatoes have been carefully selected, the next step in the process is washing. Picture large conveyor belts carrying the potatoes into enormous washing stations where high-pressure jets of water blast away any dirt, debris, or residual chemicals. The water used is not just any water, it's filtered and recycled through multiple stages to maintain the highest standards of hygiene and sustainability. Workers and machines work side by side here, ensuring every potato is perfectly clean. The vibrant colors and textures of the raw potatoes glistening under the wash lights create a mesmerizing visual, a reminder of the natural origins of this industrial process. After the thorough cleaning, the potatoes are guided into peeling machines. These sophisticated devices are engineered to remove the skin with minimal waste while preserving the integrity of the potato flesh inside. The peeling process is both a marvel of modern technology and an art form in itself. Machines adjust to the size and shape of each potato, ensuring an even peel every time. For those potatoes that still require a bit of manual touch-up, skilled workers step in to guarantee perfection. The combination of technology and human expertise ensures that every potato is prepared to become the perfect French fry. Clean, peeled, and primed, the tubers are now ready to take the next big leap in their journey. Now comes one of the most critical steps in making French fries: cutting. Here, precision is key. The clean, peeled potatoes are transferred to automated cutting machines designed to slice them them into perfectly uniform strips. Uniformity is essential not only for aesthetic reasons, but also to ensure even cooking. Each cut must be just right to guarantee that every fry cooks at the same rate and reaches the ideal crispiness. Imagine the rhythmic hum of the slicing machines as they work in unison. The machines are calibrated to cut each potato into strips of the same size and thickness with a precision that would make a master chef proud. The resulting potato strips, glistening with freshness, fall gracefully onto a conveyor belt, ready for their next transformation. For some factories, the process involves multiple cutting stages. The initial cut might shape the potato into thick wedges, which are then refined into the slender sticks that most of us recognize as French fries. This two-stage process ensures that the fries have a satisfying crunch on the outside while remaining soft and fluffy on the inside. During this stage, the factory floor is alive with energy. Operators monitor the machines closely, making small adjustments to account for any variation in potato size or texture. It's a perfect blend of machine efficiency and human intuition, a true testament to the precision of modern manufacturing. With the potatoes sliced and ready, the next step is blanching, a process that might seem surprising but is absolutely essential to achieving that perfect fry. Blanching involves briefly immersing the potato strips in hot water or steam. This step serves multiple purposes. It helps to remove excess starch, sets the color, and pre-cooks the fries so that they finish perfectly during the final frying. In the blanching stage, the fries enter large tanks or continuous steam tunnels. The water is maintained at an optimal temperature to gently cook the potatoes without softening them too much. The process is quick, just a few minutes, yet it makes a huge difference in texture and taste. By removing excess starch, the fries are less likely to clump together during frying, resulting in individually crisp pieces that are easier to season and enjoy. During blanching, you can almost see the transformation taking place. The raw, vibrant potato strips begin to take on a more uniform appearance, readying themselves for the next heat-intensive step. It's like watching a caterpillar transform into a butterfly. Each stage is critical in the metamorphosis that leads to the final, irresistible snack. Now comes the heart of the process, the frying. Once the fries have been blanched, they are carefully removed from the hot water and drained. They then move on to the frying section, where the magic of crispiness truly happens. The fries enter deep fryers filled with oil that has been preheated to the perfect temperature. In this controlled environment, the blanched potato strips are submerged in hot oil. The transformation is immediate. The water inside the potatoes turns to steam, puffing up the fries, while the oil crisps the exterior into a delectable golden crust. It's a high-energy ballet of heat and texture. Factory fryers are marvels of engineering. They are designed to maintain a consistent temperature, ensuring that every batch of fries is cooked evenly. Automated timers and sensors monitor the process closely, taking the guesswork out of frying. After frying, they are quickly transferred to a cooling system where excess oil is drained away, ensuring that every fry is light, not greasy. This careful balance of heat, timing, and precision is what creates the iconic French fry texture we all crave. The finishing touch. Once the fries have cooled, the next stage is all about quality control and that final burst of flavor. In any factory, quality is paramount, and this is no exception. Every batch of fries is subjected to rigorous checks. Automated sensors, as well as experienced quality control teams, examine the fries for the ideal golden color, uniform size, and perfect texture. Any fry that doesn't meet the high standards is set aside, ensuring that only the best reach you. Next comes the seasoning process. The cooling fries are gently tossed in a precisely measured blend of salt and, in some cases, other proprietary seasonings. The seasoning process is as much an art as it is a science. Too little seasoning and the fries might taste bland. Too much and they could be overwhelming. The goal is to enhance the natural flavor of the potato while adding a satisfying burst of saltiness with every bite. The seasoning machines are designed to evenly distribute the spices. As the fries tumble along on a conveyor belt, a fine mist of seasoning settles over them, clinging to every surface. With the seasoning complete, the fries are now ready for the final step: packaging. This stage is where all the hard work comes together and the fries are prepared for their journey to stores, restaurants, and ultimately your plate. In the packaging section, automated lines take over. The seasoned fries move along carefully calibrated conveyor belts where they are sorted into portions that meet precise weight standards. Modern packaging machines then seal the fries in airtight bags or boxes to preserve their freshness, crunch, and flavor. The packaging not only protects the fries during transport, but also serves as a visual reminder of the quality and care that went into making them. The design of the packaging often reflects the brand's identity, bold, eye-catching graphics paired with messages that highlight the quality and care of the production process. As you watch the packaging line in action, you see a symphony of robotics and human oversight working in tandem, ensuring that each package is a promise of delicious, crispy perfection before leaving the factory. Each package is given one final quality check. Automated scanners and visual inspections confirm that the right quantity is packaged and that the fries inside maintain the ideal texture and flavor. Once approved, the packages are boxed up and loaded onto delivery trucks, ready to make their way to markets, restaurants, and eventually to your table.
Have you ever wanted to know the secret to making a ton of your favorite fluffy treats? Join me as I explore the enchanting realm of marshmallow production, where innovative technology combines with delightful imagination. The story is told by marshmallows, those fluffy, sugary clouds that everyone loves to munch on. We can't get enough of marshmallows, whether we're roasting them over a campfire, mixing them into a mug of hot chocolate, or simply eating them straight from the bag. However, have you ever pondered their production process, particularly in light of the staggering volumes we witness nowadays? Watching this film will give you an exclusive peek into a marshmallow giant factory, where cutting-edge machinery produces millions of these delicious delights every day. We will demonstrate this intriguing procedure in its entirety, beginning with the selection of high-quality ingredients and ending with their packaging. I can assure you that it is both enchanting and mouth-watering. Let's go back in time for a moment so we can understand the historical context and origins. Were you aware that the origins of marshmallows can be found in ancient Egypt? In fact, honey and almonds were originally added to marshmallows prepared from plant sap. The French later perfected the recipe and made the sugary delicacies that we know and love today, which is quite a few centuries later. However, marshmallows did not begin their transition from a high-end treat to a mass-produced candy good until the 19th century. The true paradigm shift occurred during the Industrial Revolution, which ushered in industrialization. The demand for hand-piped marshmallows was increasing, so makers had to think significantly larger to meet them. Technology found its way in at this point. Modern megafactories take the idea of mass-producing marshmallows to a whole new level, consistently and precisely producing millions of marshmallows every day. This capability was first introduced in the 20th century. Where to find raw materials and ingredients? So let's get down to the ingredients. Sugar, corn syrup, gelatin, and flavorings are the simplest components that bring marshmallow enchantment. No ordinary sugar or gelatin will suffice, though. Big companies only use materials from suppliers that are at the very top of their game when it comes to quality. For the perfect marshmallow, you need 3 ingredients: pure sugar, corn syrup of the proper viscosity, and gelatin, which gives the candy its distinctive texture. Ensuring these substances are of the highest quality is no easy task. Prior to entering the production line, substances undergo rigorous testing to ensure their purity and pH levels. Imagine it as a screening process where only the most deserving chefs pass. There is a strong emphasis on using products that are as natural and sustainably obtained as possible in today's environment, as customers are becoming more health concerned. Speaking of sustainability, a growing number of manufacturing facilities are switching to more environmentally friendly methods of sourcing their raw materials. One example is the growing trend of purchasing gelatin from companies that practice sustainable farming. Gelatin is often made from animal collagen. Also, non-GMO corn can be used to make corn syrup, which is an important component. This is a baby step toward making our baked goods less harmful to the environment. Sugar and corn syrup. Okay, now we can dive into the specifics of producing marshmallows. The foundation mixture must be prepared first. For this, you'll need exact measurements of corn syrup and sugar. The next step is to bring the ingredients to a certain temperature, which will thicken and stickyify the combination. This syrup will subsequently form the sugary base of our marshmallows. While the corn syrup and sugar are simmering, the gelatin is made in a separate pot. To make sure it's completely melted and ready to blend, it's dissolved in water and heated. Because it provides structure, gelatin is essential to marshmallows. Without it, the sweet treat would just be a sugar pool. The exciting part starts with the flavors and additives. A wide range of colors and flavors, both natural and artificial, can be added to the combination in factories. With this stage, you can personalize it to your heart's content, whether it's traditional vanilla, strawberry, or chocolate. Additionally, we must not overlook the additives, which are substances that either lengthen the marshmallow's shelf life or keep them from sticking together. Cutting-edge methods for blending mixers with a high speed. When everything is prepared, the ingredients are mixed using high-speed mixers. The unsung heroes of the marshmallow world are these industrial mixers, which blend everything to a smooth, consistent texture. The automatic mixers eliminate human mistake in batch mixing, which is crucial in the production of marshmallows due to the importance of time. In this stage, temperature control is of the utmost importance. If the temperature is too high, the combination will be excessively watery. If it's too low, it will be nearly hard to handle. To make sure that every marshmallow has the same delicious texture, modern factories use precise temperature control systems to maintain the mixture at the ideal temperature. The aeration phase, which is responsible for marshmallow's characteristic puffiness, comes next. Modern aeration technology is used to whip air into the mixture, resulting in uniform distribution of microscopic bubbles. To make marshmallows that are fluffy, light, and delicious to bite into, this is an essential step. Now that the mixture is ready, shape it with the help of an extrusion machine. To make lengthy, continuous strands of marshmallow, modern extrusion machines are able to push the airy mixture via nozzles. Engineering wonders, these machines can crank out thousands of feet of marshmallow rope every hour. High-speed cutting mechanisms chop the marshmallow ropes into uniform pieces as soon as they come out of the extruder. These machines are incredibly accurate. They can shape marshmallows into any desired shape, be it a perfect cube, cylinder, star, or heart. Speaking of personalized shapes, marshmallow companies frequently employ interchangeable molds and dies to produce a wide variety of designs. Thanks to today's technology, you may find anything, from the basic cube to something completely new. The newly sliced marshmallows are coated with cornstarch so that they don't stick to one another. This process is rooted in both tradition and necessity. For decades, marshmallows have been kept soft and separated using cornstarch. But why limit yourself to only the outside? The use of precise injection technologies allows for the insertion of fillings or taste to some marshmallows. A whole new level of flavor complexity may be achieved with these current techniques, whether it's a blast of fruit flavor or a gooey chocolate center. As if that weren't decadent enough, certain marshmallows are given an extra dose of luxury with unique coatings. Coating machines that run on conveyors take ordinary marshmallows and transform them into gourmet treats by adding chocolate, coconut, or even sprinkles. The production of millions of marshmallows makes automated inspection a must for ensuring product quality. Every marshmallow is inspected for uniformity in size, shape, and texture using high-speed cameras and inspection systems powered by artificial intelligence. Only the finest marshmallows make it to packaging because these technologies are so sophisticated that they can detect the tiniest faults. As part of their quality control procedures, companies take samples from each batch and put them through in-lab testing alongside automated inspections. To make sure the marshmallows retain their delicious flavor even after being stored for a while, these tests measure characteristics like texture and flavor stability. No amount of technology can guarantee that mistakes won't occur. For this reason, manufacturing facilities contain mechanisms to identify and address any discrepancies that may arise. These mechanisms make sure that any problems, such broken machines, or mixed-up ingredients are identified and fixed fast. The next step is to package the marshmallows if they pass inspection. Fully automated packaging lines allow modern companies to pack each marshmallow rapidly and hygienically. While keeping to the strictest of hygiene standards, these lines can fill and seal bags with ease. To keep them fresh for longer, many marshmallows are vacuum sealed to eliminate air, which shortens their shelf life. From the factory to your cupboard, these marshmallows will remain fresh and fluffy thanks to this technology. Last but not least, high-speed labeling equipment are used to label and brand the packaging. These machines check that all of the necessary features, such as the brand's emblem and nutritional information, are printed on each package. Transporting marshmallows in a temperature-controlled environment is of the utmost importance when it comes to cold chain logistics. Whether they're being sent across town or across the globe, cold chain logistics keeps marshmallows tasting great the whole way. In the background, sophisticated tracking technologies keep an eye on the whole distribution network, guaranteeing that the marshmallows will reach their destination promptly and undamaged. The supply chain cannot function reliably and efficiently without these systems. Sustainable manufacturing has seen a significant uptick in support in recent years, and this trend has led to some interesting innovations in the marshmallow industry. Companies are decreasing waste, recycling production byproducts, and investing in energy-efficient machinery. In addition to helping the environment, these initiatives will likely appeal to the growing number of customers seeking out green items. The manufacturing of marshmallows is being transformed with the advent of AI and robots. These technologies are enhancing production speed, efficiency, and precision, with examples including AI-driven quality control and robotic arms handling packing. We should anticipate even more advancements in the future as AI keeps becoming better. So after marshmallows, what's the plan? More nutritious alternatives with less sugar are on the rise, as are marshmallows with unique flavors sourced from all over the globe, and even vegan and gluten-free varieties to meet individual dietary demands. What the future brings for this timeless delight is anyone's guess, and the possibilities are thrilling. It takes a lot of effort to make millions of marshmallows daily. Ensuring uniformity and high quality in such massive volumes is a major obstacle. To maintain such high standards, factories must continually monitor and tweak their procedures to guarantee that every marshmallow satisfies them. Production of marshmallows can be significantly affected by disruptions in the global supply chain. Manufacturing facilities need to be ready to respond rapidly to unforeseen challenges, such as ingredient shortages or transportation delays. Maintaining uninterrupted manufacturing typically necessitates having backup suppliers or alternate transportation routes. In the end, companies need to follow all the rules and regulations that pertain to the food sector, including those that concern health and safety. There are strict regulations covering everything from hygiene to labeling, and businesses risk closure or heavy fines if they don't follow them. That is why it is paramount for every big factory to comply with regulations. Personalization is king in today's industry. For parties, events, or other special occasions, customers may now place orders for marshmallows in a variety of forms, colors, and flavors through some mega manufacturers' custom marshmallow services. In today's cutthroat business climate, this trend is both a fun and strategic strategy to attract and retain customers. Online and social media campaigns are quite important. In an effort to engage customers and foster brand loyalty, companies are getting inventive, using anything from Instagram-worthy photographs to popular TikTok videos. Lastly, interactive tours are becoming more common, with some manufacturers even welcoming the public through virtual or in-person visits. These tours provide customers an opportunity to witness the making of their favorite sweets up close and personal, giving them a glimpse into the production process Establishing credibility and establishing a stronger bond with customers can be achieved through this method. So there you have it, the complete process of making a marshmallow from start to finish. It's a method that combines old and new ways of making one of the most famous candies in the world, utilizing industrial technology. Conclusion: the creation of marshmallows exemplifies the remarkable progress we have made in the field of food processing, as we have seen.
Hey there! Have you ever pondered where a brightly colored gummy bear came from while holding it in your fingers? That little chewy treat is an intellectual, historical, and culinary marvel, not to mention a nibble. The modern industrial marvel that is gummy candy didn't begin as something that children and adults alike adore. It all started in the home of Hans Riegel, a confectioner from Germany. In the early 1920s, he started experimenting with a copper pot and a stove as his only tools. What was the outcome? The world of candies was forever changed when the gummy bear was born. The intriguing method of making gummy candy in modern factories is explored in this narration. Every stage of the manufacturing process, from ingredient selection to quality control, showcases the remarkable combination of human creativity and technical progress. Join me on this delicious adventure. Hans Riegel established Haribo in 1920 in Bonn, Germany. The story starts there. He created the first gummy bear in 1922, influenced by the European circus's famous dancing bears. These chewy sweets were first marketed in modest numbers, but swiftly became a worldwide phenomenon. The method and formula have changed over the years, incorporating new flavors, forms, and colors, as well as state-of-the-art technology. These days, you can get gummy sweets in every shape imaginable, from rings to worms and even vitamins. Gummy candy has changed over the years to mirror both technological development and shifting customer preferences. The components for gummy candy are hand-picked to guarantee uniformity in quality and flavor. A chewy texture is characteristic of gummy candy, and gelatin is the main ingredient responsible for this. Collagen is made from animal sources, specifically pig and cow bones and connective tissues. Because of its rigorous purification process, this gelatin has no flavor or smell, making it ideal for use in candy making. Gummy candy gets its distinctive melt-in-your-mouth quality from the thermoreversible gelatin, which melts when heated and hardens when cooled. The procurement of gelatin necessitates a meticulous supply chain. Processing facilities harvest and purify collagen from raw materials provided by farmers. To maintain sustainability and protect the well-being of the animals, these institutions adhere to stringent regulations. Manufacturers utilize a mix of sucrose, derived from sugarcane, and fructose, from maize syrup, to attain the ideal sweetness. These sugars do double duty by enhancing the candy's flavor and keeping it from drying out. Because it keeps the candy from crystallizing and keeps it smooth and malleable, corn syrup is highly prized. The production of sucrose begins in sugarcane plantations. The sugarcane is first reduced to its raw sugar form after harvesting and then refined into a candy-making consistency. This sweet treat gets its taste from molasses, maple sugar, berries, and natural fruit extracts. The distinctive aromas of various gummy forms are created by enhancing these natural flavors with aromatic chemicals. There are natural and artificial sources for colors. Vibrant and uniform hues are guaranteed by regulated dyes such as red hash 40, yellow hash 5, and blue hash 1. Beetroot, turmeric, and spirulina natural colors are becoming more popular among health-conscious consumers. The candy's texture and shelf life are impacted by the pH balance, which is achieved by adding food-grade acids such as citric, malic, or tartaric acid. Sour gummy sweets get their tart flavor from these acids as well. For instance, citrus fruits are a common source of citric acid, which is then fermented and purified for commercial usage. The ideal formula for gummy candies is developed in collaboration between food technologists and chemists prior to manufacturing. The pros here play around with different quantities of ingredients until they find the sweet spot when flavor, texture, and presentation all come together. We make sure every recipe is up to par by testing it thoroughly for quality and safety. Science and art are both involved at this period. To guarantee a consistent quality and aesthetic appeal in the finished product, laboratories with cutting-edge equipment test the interactions of substances under different settings. There are a lot of moving parts on the road from raw ingredients to an ideal chewy gummy sweet. Here, we will dissect it. In large tanks designed for industrial use, the raw components are measured and blended to begin the compounding process. To maintain consistency, these tanks have state-of-the-art heating and cooling systems. At high heats, gelatin dissolves in water. Next, flavors, colors, and sweeteners are added one by one. To make a smooth candy base, stir often to avoid burning and to make sure it's heated evenly. To guarantee accurate measurements, human workers and automated systems work together. Before going on to the next step, sensors check the base's temperature and viscosity to make sure it passes all of the requirements. The next step is to mold the candy after the base is complete. As a molding medium, starch is utilized in this step by a specialized machine called the mogul. In addition to absorbing excess moisture and keeping the candy's shape while it cools, starch also prevents stickiness. Starch in trays. After leveling the surface, empty trays are filled with starch. To make the forms you want for your candies, all you need is a board that has molds on it to press into the starch. To fill the molds, a precise nozzle is used to pour the candy mixture into each cavity. Sweets that are both aesthetically pleasing and delicious can be made by the mogul using a combination of colors and tastes. The loaded trays are then transferred to a refrigeration chamber and left there for more than 24 hours. The candies get their signature texture and firmness from the lengthy cooling process. The candies are set at the ideal temperature and humidity during this period, so they don't get too sticky or hard. These circumstances are constantly being monitored by engineers who make adjustments as necessary. After the trays have cooled, they are turned upside down so the sweets can drop onto a vibrating sieve. The candies are cleaned and prepared for additional processing by using this sieve in conjunction with oscillating brushes to remove extra starch. To further increase their aesthetic value, gummy sweets may be subjected to other finishing processes after demolding. The sweets get their glossy, smooth appearance from a thin coating of wax or polishing agents. Because of its natural origins and glossy look, carnauba wax, made from the carnauba palm tree's leaves, is a popular choice. To enhance the texture and flavor of some gummy candies, they are coated with sugar or sourness. For sour gummies, this is a popular choice. Tumbling machines are used to apply these coatings in a uniform fashion. Before they are packaged, the completed sweets are separated and checked for quality. The packaging process is handled by automated machinery, which ensures efficiency and consistency. Packaged in airtight bags, boxes, or jars, these sweets are prepared to be distributed to retailers all around the globe. The function of packaging extends beyond mere containment. It serves as a means of branding as well. Products are attractive and convenient for consumers because of their vibrant appearance and resealable characteristics. Making sure the gummy candy is of high quality is an important step in the process. To guarantee it satisfies specified criteria, every batch is tested extensively. Lab testing verify the chemical qualities, including pH and moisture content, while sensory panels assess the sweet's look, texture, and flavor. The raw materials are the first point of quality control. In order to guarantee a steady supply of premium ingredients, all suppliers are thoroughly reviewed. To guarantee the product meets expectations, random samples are taken at each step, from mixing to final packing. The production of gummy sweets exceeds 160 million per day on a global scale. Gummy bears and worms are the two most beloved shapes of gummy candies. More complex confectionery shapes are being considered using cutting-edge technologies such as 3D printing. For those who are looking for a nutritious snack, there are gummy sweets that have been enhanced with vitamins. There are a lot of moving parts in making gummy candies.
Think about the last time you unwrapped a Twix bar, that satisfying crinkle of the gold wrapper, the irresistible aroma of chocolate, and that first bite where the crisp biscuit meets the gooey caramel. It's pure magic. But have you ever wondered what goes on behind the scenes to create this iconic treat? Today, we're pulling back the curtain to show you the fascinating step-by-step process that transforms simple ingredients into the Twix bars we all love. From state-of-the-art machinery to innovative techniques, every step is a blend of precision and passion. Get ready to discover the sweet science behind the candy bar that's been stealing hearts for decades. The story of Twix starts with the foundation, the biscuit base. But don't let its simplicity fool you. This crunchy layer is the backbone of the entire bar. Inside the factory, enormous mixers, some as tall as a two-story building, whirl together a perfectly balanced blend of flour, sugar, butter, and a touch of magic. This isn't just any shortbread dough, it's engineered to deliver that iconic snap with every bite. As the dough comes together, sensors monitor its texture and temperature, ensuring it's neither too dry nor too sticky. Once perfected, the dough is transferred onto a conveyor belt that feeds it into a sheeter. Picture this. The dough emerges as a flawless, continuous sheet, gliding effortlessly down the line. Next, cutters, like giant cookie stamps, press out those familiar biscuit shapes. Each stamp is precise, creating thousands of identical biscuits every minute. The journey doesn't stop there. These raw biscuits enter industrial ovens that are nothing short of technological marvels. Imagine rows upon rows of biscuits riding through the oven, where the air is infused with the irresistible aroma of baking shortbread. Inside, temperatures soar to the perfect degree, creating that golden brown hue while locking in the biscuit's crisp texture. It's a sensory delight, even if you're just watching. As the freshly baked biscuits cool, the factory prepares for the next step, adding the gooey caramel layer. This isn't a process to be rushed. The caramel starts in giant stainless steel vats where sugar, butter, and milk are gently heated and stirred. Picture a cauldron bubbling away, with the mixture slowly transforming into liquid gold. Workers oversee this process with the help of advanced technology, ensuring the caramel reaches just the right consistency, sticky enough to stay put, but soft enough to melt in your mouth. When ready, the caramel is funneled into precision nozzles stationed above the conveyor belt. Here's where the magic happens. As the biscuits glide underneath, each nozzle dispenses a perfectly measured dollop of warm caramel. Watching this process is oddly mesmerizing as the golden ribbons of caramel settle neatly onto the biscuit bases. But the process isn't over yet. The caramel needs to cool, allowing it to adhere firmly to the biscuit and prepare for the next step. This pause might seem insignificant, but it's crucial to maintaining the structural integrity of the final product. And now, the pièce de résistance, the chocolate coating. This is where the Twix bar becomes the indulgent treat we know and love. In another part of the factory, giant vats of milk chocolate are kept at a carefully maintained temperature. It's a chocolate lover's dream, a rich, molten river of sweetness, ready to drench the caramel-topped biscuits. The enrobing process is like a culinary performance. As the biscuits approach, they pass through a curtain of liquid chocolate. Imagine a waterfall of molten chocolate cascading down, enveloping each bar in a smooth, glossy coat. It's not just about appearance. This step ensures that every bite delivers the perfect balance of flavors. Any excess chocolate drips off into collection trays below, where it's recycled back into the system. Nothing goes to waste. From here, the chocolate-coated bars enter a cooling tunnel, a refrigerated conveyor belt that rapidly hardens the chocolate while preserving its sheen. The tunnel is precisely calibrated to cool the chocolate without compromising its smooth texture. By the time the bars emerge, they're shiny, firm, and ready for the next stage. Here's something you might not know. Not every Twix bar makes the cut. The factory employs a range of quality control measures to ensure only the best bars reach consumers. High-speed cameras, strategically placed along the production line, inspect each bar for consistency in size, shape, and caramel alignment. These machines are so advanced, they can detect even the tiniest imperfections. Bars that don't meet the exact standards are gently removed from the line, but don't worry, they're not wasted. Many are melted down and recycled back into the production process. In addition to automated checks, human testers sample bars from every batch to ensure the taste, texture, and appearance are spot on. It's a meticulous process, but it's what guarantees that every Twix bar delivers the same delightful experience. Once the bars pass quality control, they're ready to be wrapped. This is where the iconic gold wrapper comes into play. These wrappers are printed in-house using state-of-the-art machines that ensure vibrant colors and precise cutting. As the bars move down the line, they're enveloped in their shiny gold coats, sealed tight to lock in freshness. Packaging machines operate at incredible speeds, wrapping hundreds of bars per minute. But it doesn't stop there. The wrap bars are sorted into various packs, individual, twin packs, or bulk boxes, depending on market demand. From here, they're loaded onto pallets and shipped to warehouses across the globe. The logistics are a marvel in themselves, ensuring that Twix bars arrive on store shelves as fresh as the day they were made. What sets Twix apart isn't just its taste, it's the cutting-edge technology behind its production. Mars Incorporated, the company behind Twix, is constantly innovating to improve efficiency and sustainability. Many Twix factories now use AI-powered systems to monitor energy usage and reduce waste. These systems can adjust machinery settings in real time, ensuring optimal performance with minimal environmental impact. Another fascinating innovation is the use of robotic arms for tasks like stacking and palletizing. These robots work tirelessly, performing repetitive tasks with precision and speed. This not only boosts productivity, but also enhances workplace safety by reducing the risk of injury for human workers. Did you know that a single Twix factory can produce over 1 million bars in just one day? That's enough to stack from the ground to the top of the Empire State Building multiple times. Here's another tidbit. Factories use special sensors to measure the viscosity of caramel, ensuring it flows perfectly onto each biscuit. And the machines? They're custom-built to handle Twix's unique layered design, making the production process as special as the candy itself. While the classic Twix recipe remains a fan favorite, different countries have put their own spin on it. In Japan, you'll find matcha green tea Twix, offering a delicate blend of sweet and earthy flavors. India has its own twist, with spicy masala Twix, catering to fans of bold, savory snacks. Down under in Australia, mango-flavored Twix bars bring a tropical vibe to the table. These regional variations are often produced in limited quantities, making them a treasure for collectors and candy lovers alike. Mars Incorporated isn't just about making great candy, it's about making a positive impact. Many Twix factories now run on renewable energy sources like wind and solar power. The company has also committed to sourcing cocoa and palm oil responsibly, ensuring that their ingredients are as ethical as they are delicious. By investing in sustainability, Mars is not only preserving the environment, but also ensuring a bright future for its beloved brands. Love learning about how your favorite snacks are made? Then join us on this sweet adventure. Hit that like button, subscribe to our channel, and ring the notification bell so you never miss an upload. And we'd love to hear from you. Drop a comment below and let us know which treat you'd like us to feature next. Share this video with your friends and family, and together, let's celebrate the magic of candy making.